We're good? All right, thanks.
Yep.
Hey, Mia team. Hope you're doing well out there. We all miss you over here. We've been, as you probably know, we've been pitching a lot of VCs recently. And one part of our pitch is kind of this technical overview of all the stuff that we built and why it's great and how it's going to prevent other competitors from catching up to us. And so Spencer wanted, I shared this at all hands last week, but the recording got cut off. So Spencer wanted me to go over it for you guys. So here we go. As you probably know, the major part of the pitch is how we're helping people understand user behavior and how we can link product to business outcomes. And kind of the key technical impact or key technical part of that is this concept of complex distributed joins. You should take a look at the Series C deck in Drive to kind of see the build up to that, but I'll be going into kind of how I talk to VCs about our technology in the context of this business problem. So we'll focus on what I just talked about, complex distributed joins. And you might be wondering what these actually are, and all VCs also wonder the same thing. So I'll break it down, each of these words. Turns out that all of these words are very important, and so if you drop any of them, it becomes kind of an uninteresting problem, and that's the part VCs really like to hear. All right, so we'll start off with joins. This is kind of a database terminology term, but you can, it's pretty easy to understand in the context of just normal things. When you're doing analysis on any data set, simple analysis kind of consists of looking at each data point you have, whether it's a row in a database or an event in our system, for example. And if you can make a determination about what you're trying to calculate based on just that data point, it's a non-join query. So let's say you're just counting the total number of events, right? You just look at an event, that's +1, look at another event, +1, and so on. Joins, on the other hand, are when you need to actually pull together many different rows or data points or events in order to make to actually figure out the answer to the query. So if you think about a funnel or retention query, you actually need to look at multiple events and kind of piece those together in order to decide whether a user converted through the funnel. So that's the concept of a join. And so a lot of behavioral queries become joins. Distributed is an easy one. And we just have a lot of data. Our customers send us a lot of data. They have a lot of users, and so you can't do that. You can't do the queries on a single machine. You have to spread the data out and then run a distributed computation. Lastly is complex. And if you look at the spectrum of the types of queries that we do in our product, the types of features that we have, and compare it to kind of stuff out there, 5 years ago, funnels and retention may have been at the expert end of product analytics. Those are like the most advanced things that people look at, and those are relatively simple from a join perspective. You pull together a few events and then you can calculate the funnel. The stuff we do today, ranging from Pathfinder, which is like user flows actually aggregated, or personas, which is building behavioral profiles for people and then clustering that. Those are much more complicated computations on top of the data, and they're also joins. And so this is kind of the confluence of these three aspects leads to interesting technical problems, and that's why VCs want to hear about, like, how do we solve this and why why is the way we're doing it better. All right, so then I got to follow up with this big circle of what I call real-time interactive analytics bubble. And everything we do is pretty much inside this bubble. And that's for a couple reasons. One, real-time is obviously really important. There's two kind of components to that. One, the first is people really only trust the data if they can see it happening in real time. If you imagine a database or service where you put data in and then you don't see it for hours or days, it's just really hard to make sure that that's actually doing what you expect it to do. And the second aspect is, Justin likes to tell this story from Joya a lot, where they are a super advanced project organization that moves really, really fast. And they might deploy their product multiple times a day. In that case, you really want real-time data and feedback and understanding that the new release you had didn't break things, or the new feature you just shipped is actually behaving properly. Real-time becomes really important, and as more of our customers become advanced like that, that's a big part of Interactive is more straightforward. We expect people to do a lot of deep analysis in Amplitude, and that means they're going to be asking a lot of questions. And they're going to be making a lot of hypotheses and either validating or disproving those, and then asking further questions. And so in order to get people to iterate a lot, you need to have an interactive experience. Like queries can't take a long time. That's why we care a lot about performance. And yeah, so interactive is a big part of how we expect people to be analyzing data, even today, but certainly more in the future. All right, so inside this bubble of real-time interactive analytics, I first start out by kind of describing the existing technologies out there and what databases traditionally do. So along this axis, there's this trade-off on one end of pre-computation. Hopefully this is big enough that you guys can read it. If not, you can always ping me to figure out what those words are saying, but I'll also be talking a lot about them. And on this side, there's SQL. So on the pre-computation side, what are the benefits of pre-computation? So if you know, for example, what distributed joins that you want to compute, and you've already decided that these are the interesting queries, it's really easy to just compute them before a user even asks for it. And so in that case, it's really easy for things to be fast, cost efficient, because you only need to do that computation once up front, and then you just, when you serve the query, it's just instant. The downside, obviously, is that it's very inflexible, because by the nature of computation, if a user asks you a query that you haven't already decided was useful, you just can't answer it. Great. So that's pre-computation. SQL is almost the opposite. SQL, the main benefit is it's super flexible. It's a query language that lets you express all sorts of different things. But the downside is, in order to do complex distributed joins at scale, you either are going to have a really slow database. So you can think of our Redshift offering. While it's pretty useful for the flexibility, a lot of times when you run queries there, they're just super slow, and that's just the reality of it. The alternative to slow is very expensive. If you paid enough money, you could probably get a SQL database to do your complex distributed joins, at a reasonable rate, but that's going to be very pricey. Okay, so what's the story of Amplitude and how we fit into this landscape? First of all, we started actually over here. Some of you, probably not a whole lot of you out there will remember, but we used to do a lot of pre-computation. Because at the time that we entered the space, Mixpanel already existed. They're kind of over here, and they were doing a decent number of queries. They had segmentation, funnels, retention. They were really reasonably fast, but it was very expensive. And what we realized is that fast and cost efficient is kind of an angle that we could get into the space. And we thought maybe in the realm of product analytics, there's a well-defined enough set of queries and types of analysis that people do. For example, with funnels and retention as being kind of cornerstones of that, that we didn't need flexibility. And so we built out this pre-computation system. We were able to sell it a lot for really cheap because it was cheap for us to run. But it didn't take that long. Once we acquired more customers, once customers themselves became more advanced in the way that they thought about product analytics, that we realized that flexibility was, it's not just, there is value in that. And if you go back to the really early days, you can kind of see we didn't have arbitrary segmentation along every dimension. That way back, group by wasn't even a thing. There's all sorts of kind of trade-offs that we made, and as we started adding more and more flexibility-related features, we realized that maybe this paradigm itself was not correct. Okay, so then what do we do? Where do we end up? So we realized that flexibility is important, but it wasn't arbitrary flexibility. So SQL is about arbitrary flexibility. You can represent almost any query you want. But what we realized is that behavioral analytics, the types of user joins that you're doing, that's really a special dimension. So Nova obviously is the system up here. And what we decided was that the user join dimension is the flexibility that you want for behavioral analytics. And why is that? That's because everything you're doing is analyzing users. And so if you have all the, if you can join together all the context of a user, all their events, their properties, whatever merge users and all that good stuff, once you have all that, you can make a determination for that user. whether they satisfy your query or whatever it is you're trying to calculate, whether they belong to a cluster or what aggregate user flows that they've gone through for Pathfinder. That this is really the dimension that defines product analytics itself, that all the queries are along that dimension. And so the nice thing about this is that, even though it's not pre-computation, because the flexibility is along a limited dimension, you can actually still have most of these other two benefits. So the speed and cost efficiency. They're actually still pretty good along this dimension. And it's not going to be as fast or as cost efficient as a pre-computed system because that's just the nature of pre-computation. But for our purposes of doing interactive analytics, it's fast enough that it can operate at human speed. So queries, most queries that we do take maybe a couple seconds, and that's roughly how fast people think. And so it's not critical that it's a lot faster than that. And also, that's kind of how you get the cost efficiency. You don't need to scale out a huge amount in order to push those queries into millisecond latency or anything like that. You can kind of pick your balance here and then get flexibility along the user join dimension. All right, so how did we actually get there? Well, obviously it took a lot of iterations. So we started here and then we built all sorts of kind of flexible systems in different ways. And then we iterated on those, and it wasn't until maybe halfway along this line that we realized that there was kind of a unifying abstraction of the user join, and then we built that. And so the thing about this is that the reason we had to build this was because almost all existing technologies live along this spectrum, and so it's really had to go away from this spectrum, and that's kind of why we had to build Nova. Why doesn't Nova exist? It's that it's actually kind of a specialized application of database technology to our domain, to the user join dimension in behavioral analytics. So it's like a different thing from a Redshift or a BigQuery that lives down here, or any of the tools that live on top of that, like Looker or Tableau and all that stuff. It's only by leveraging the fact that this is the type of flexibility that we care about that we can actually build a system that has the speed and cost efficiency ratio that is, that gets people to understand why, how the money they're paying actually becomes valuable. So, yeah, I think that's basically the high level of the pitch that I give VCs. And so, hopefully, you find it useful to see how Nova fits into the spectrum of database and analytics technologies. And actually, for context, I'll draw like Mixpanel or like Interana or Heap. They're almost all over here. And on this end, it's more like GA or Flurry, because they have very cheap systems, free, and that's because they don't have a whole lot of flexibility, and these are all just trade-offs. But Nova is kind of the trade-off that we make in order to have a compelling product for our customers. So yeah, that's pretty much it. If you have any questions, feel free to ping me on Slack or email. Happy to talk about this. And yeah, that's it. All right, thanks guys. Let me figure out how to stop this.